Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from Module 2022, Paper 2. In this class, we will discuss different topics from mechanics, and we will try to understand and try to improve our conceptual understanding of those topics by solving past paper questions. So watch the video carefully and try to improve your conceptual understanding of mechanics. Let's study together. Let's improve together. In today's class, we are talking about June 2022, and total time for this exam is 1 hour and 15 minutes. You need to answer all the questions on this paper, and total mark for this paper is 60. On the second page of your exam paper, some data is given to you. Means values of some important constants are given. If you need value of any constant, you can come to second page of exam paper and you can find value of constant. So this is very important. You need to be clear that values of constants are given to you. On second page of exam paper, you can also find some important formulae. But these formulae are not all the formulae you need for AS physics. But these are some important formulae about different 7 topics. But you need to understand how to derive rest of the formulae, or you need to remember. For question number 1, it is given to us a solid metal sphere has a diameter of 3.42 plus minus 0.02 centimeters and a mass of 67 plus minus 2 grams. We need to calculate density of this metal, but our answer has to be in grams per centimeter cube. We need to calculate density for this question. Very straightforward question, or we can say is a very basic question. You need to understand how to calculate density. Density is simply equal to mass over volume. So we can use capital M for the mass and we can use capital V for the volume. For this question, mass is given to us. Value of mass is 67 grams. But volume is not given. Diameter of the sphere is given to us. So first of all, we can calculate volume. Volume of sphere is equal to 4 by 3 pi r cube. In the question, we have diameter, so we have to convert diameter into radius. Diameter is 3.42 centimeters. We need to divide diameter by 2, so this is radius now. We need to take cube of this. If we take cube of this and we solve for volume, our answer will be 20.9 centimeter cube. So this is volume of sphere. Now simply we can plug in this value here. So this is 20.9 centimeter cube, and we can solve for density. Our value of density will be equal to 3.2 grams per centimeter cube. So this is value of density. So this is our final answer, and this is how you can calculate density. For this question, we have 3 marks, and the first mark will be given to you if you have written this formula. So it's very important that you write down all the steps. You can see in this case, if you simply write down the formula, you will get 1 mark. And the second mark you will get if you have got right value of volume. So this is the second mark. And the last mark is the answer mark. If you have got the right answer, you will get this mark. So this is how marks will be awarded. From this question, you need to understand, you need to write down all the steps all the time. You can see if you only write down the formula, you will get 1 mark. So always write down all the steps. For part B, we need to determine the percentage uncertainty in the density. But for this question, we have diameter of the sphere and we have mass of the sphere. And we have also discussed about density, that density is equal to mass over volume. Now we need to look at these quantities. As these two quantities are divided, so the percentage uncertainty in rho will be equal to percentage uncertainty in mass plus percentage uncertainty in volume. Percentage uncertainty in volume. Now first of all, we need to understand volume is equal to 4 by 3 pi r cube. For this question, we have diameter, so we can rewrite this one. So we can write down in terms of diameter. So radius is equal to diameter divided by 2. We need to take cube of this. So if we simplify this one, we will get this is 4 by 3 pi d cube divided by 8. We can further simplify this one. We can cancel this 4, and here we will get 2. Means simply we divide 8 by 2 and we can cancel 4. So we left with pi by 6, and this is d cube. Pi is a constant and 6 is also constant. So there is no uncertainty in constants. So it simply means that we need to consider percentage uncertainty in diameter. As diameter, it has power, means it has exponent. So exponent has to come in front of percentage uncertainty. So here we need to consider percentage uncertainty in diameter. This is the main concept what we need to answer this question. Now simply we need to calculate percentage uncertainty in mass and percentage uncertainty in diameter. In order to calculate the percentage uncertainties, we need to write down absolute uncertainty of mass divided by value of mass itself, and we need to multiply this one with 100 because this is percentage uncertainty, and we will use the same method for diameter. So we will have absolute uncertainty of diameter divided by value of diameter, and this one we need to multiply with 100 because this is percentage uncertainty. Now simply we need to plug in values. So we have absolute uncertainty for mass, that is equal to 2 divided by 67. We need to multiply this one with 100 plus 3 times we have absolute uncertainty of diameter, that is 0.02, and we need to divide this one by value of diameter, that is 3.42, and we need to multiply this one by 100 because this is percentage uncertainty. If we simplify, we can get value of percentage uncertainty in density. So this is percentage uncertainty in density. Percentage uncertainty you can write up to 2SF, or simply you can use 1SF. It is acceptable up to 1 or 2 SF. So in this case we will write down our answer up to 2 SF. So this is the final answer. This question has 2 marks. The first mark you will get if you have written this step. If you have written this step, you will get 1 mark. And the second mark you will get if you have got the right value of percentage uncertainty. For question number 2, it is given to us: an archer releases an arrow towards a target at a velocity of 65 meters per second and at an angle of 4.3 degrees above the horizontal, as shown in figure 2.1. When arrow is released, the tip of the arrow is at a horizontal distance of 70.0 meters from the target and 1.66 meters above the horizontal ground. The arrow hits the center of the target. We can assume for this question that air resistance is negligible and that all the mass of the arrow is at its tip. For part A, we need to show that the time taken for the arrow to reach the target is 1.08 seconds. In this question, we will treat arrow as a point mass because in this question, it is given to us all the mass of the arrow is at its tip. So simply we can treat this arrow as a point mass. Now we need to understand the motion of this arrow. So the motion of this arrow is like projectile motion. So this will go first of all up, it will reach the maximum height, and then it will start moving downwards. So the motion will be somewhat like this, and it will hit the center of the target. We can also draw horizontal line here so you can see this motion in a very clear way. So this is what you will see how this arrow will move. For this question, we need to calculate the time taken. In order to calculate time taken, we can only take its horizontal motion. For horizontal motion, horizontal displacement is given to us. Then also we can resolve this one into its components, means the velocity of arrow we can resolve into its components. Velocity of arrow is 65 and angle is 4.3 degrees. So it has horizontal component and it also has vertical component. So the horizontal component in this case we can write down that will be equal to 65 cosine of 4.3 degrees. Horizontal displacement is given, but it is also given to us there is no air resistance. So it simply means that there is no acceleration along horizontal. So AX is equal to 0. So simply we can say horizontal displacement means SX, that will be equal to simply UX times T, means the total time taken. We need to calculate total time taken, so we can write down horizontal displacement divided by horizontal component of velocity, initial velocity, and that component will stay constant all the time. Now simply we need to plug in values. We have horizontal displacement, that is 70.0 meters, and we have horizontal velocity, horizontal component of initial velocity, that is 65 cosine of 4.3 degrees. If we solve this one, our answer will be about 1.08 seconds. And this is what we need to show, that T is equal to 1.8 seconds. And this question has 2 marks. The first mark you will get if you have written this formula. So you will get 1 C mark. And if you have got the right answer, you will get second mark, and this is A mark. For part B, we need to calculate the height of the center of the target above the ground. It simply means that at this point we have center of this target. We need to find out this height. Let's say this height is equal to small h. And this height, this one, let's say this is equal to capital H. So this height is given to us, and this is equal to capital H. Now we need to consider motion of this arrow. We have already discussed, so let's redraw that. This arrow, first of all, will go up. It will reach maximum height, and then this will start falling downwards. So this will go like this, and finally this will hit this target. We can draw horizontal line. So this is the horizontal line. Let's try to understand how we can calculate value of small h. This is what we need to calculate. In order to calculate h, if we can find out this vertical displacement, then it will be very easy to calculate value of small h. Let's say this vertical displacement is equal to d. Now in this case, we can simply write down capital H. This is equal to d plus h. We need to calculate small h, so we can write down this will be equal to h minus d. Value of capital H is given, that is equal to 1.66 meters. Now, if we can find out value of small d, means the value of the vertical displacement, then we can find out value of height. Now we need to find out value of d. In order to find value of d, we need to consider projectile motion. If we look at this point, we have the initial velocity, that is 65 meters per second, and this arrow is at an angle of 4.3 degrees. So it has two components, horizontal component and it has vertical component. We can say this component is uy. If we need to find out this value of t, we will consider motion of this arrow from this point to this point. But we have already calculated time taken from here to here, and that time taken t was equal to 1.08 seconds. We have the initial velocity, we can write down uy, that is equal to 65 sine of 4.3 degrees, and we have value of a, that is equal to 9.81 meters per second per second. This velocity is vertically up, so we can draw arrow here. This is up and this one is down, so we can draw arrow here down. We need to find value of t. In order to calculate value of t, simply we need to consider vertical motion. So let me use different color and we can answer this question. So we are talking about vertical motion only, so you have to be very clear about this one. We are only talking about vertical motion. That's the reason acceleration is equal to 9.81. Now in this case, we need to take one direction as positive. So in this case, we will take up is positive. So the value of displacement will be negative. we need to take up is positive. If we take up positive, this value, this will be positive and this one will be negative. So simply we can use in this case S is equal to ut plus 1/2 at square. S we need to find out, so that is equal to d. U initial velocity is given, that is 65 sine of 4.3 degrees, and this is multiplied with 1.08 plus we have 1 by 2 and A is negative 9.81. This is negative because this is down. We have taken up is positive and value of time we have, that is 1.08 square. Now we need to solve this one for D. If we solve this one for D, we will get answer is 0.46 meters. That this answer will be negative. Why this is negative? Because displacement is downwards. We have taken up is positive. So value of displacement, what you will get, that one will be equal to negative 0.46 meters. Simply you need to plug in this value here. So this is 4.6 meters. We are talking about height, so that's the reason we have taken positive here. So the final answer in this case will be equal to 1.2 meters. So this is value of the height and this is how you can calculate. If your concept of projectile motion is clear, you can calculate very easily. I hope this is clear to you. If you have any questions about this one, just leave your questions in comments. This question has 3 marks. The first mark will be given to you if you have written this one. So this is the first mark. If you have written this, you will get first mark. And the second mark you will get if you have got the right value of displacement, means right value of D. So this is the second C mark. And the last mark is answer mark. If you have got the right value of height, you will get the last mark, means you will get answer mark. This is how marks will be awarded to you. For part C, we need to consider energy changes and we need to state and explain how the final kinetic energy of the arrow as it hits the target compares with its initial kinetic energy after release, soon after it is released. A numerical calculation is not required. This question is simply about conservation of energy, or simply I can say this is about conservation of mechanical energy, because in this question there is no air resistance. Air resistance is negligible. So simply this is about conservation of mechanical energy. Let's try to look at motion of this arrow. We have already discussed this arrow. First of all, it will go up, it will reach the maximum height, and then this arrow will start falling downwards. So the motion of the arrow will be somewhat like this. We can also draw horizontal line here at this point. For this question, simply we need to compare the final kinetic energy with initial kinetic energy. It simply means that at this point arrow has certain kinetic energy. We can say this is initial, and when it hits the center of the target, it has certain kinetic energy. That one is final kinetic energy. Now if you look at motion of this one, when this arrow is moving up, arrow will gain GPE, means its gravitational potential energy will increase, but its kinetic energy will decrease. So simply we can say kinetic energy decrease. In this case, kinetic energy will be converted into GPE. But when this arrow will start moving downwards, means when it will start falling, in that case GPE will decrease and GPE will be converted back into KE. So when arrow will reach at the same level, at the same height, kinetic energy at this point, let's say this is kinetic energy 1, this will be equal to initial kinetic energy. But after this one, you see arrow is still falling, mean arrow is moving downwards. So as arrow is moving downwards, gravitational potential energy of this arrow will decrease. As this energy is decreasing, it means this energy will be converted into kinetic energy. So in this region simply we can draw arrow here. In this region, kinetic energy is greater than the initial kinetic energy because gravitational potential energy is decreasing. So simply we can say that kinetic energy final, if I compare with this one with initial, so the kinetic energy final will be greater than kinetic energy initial. But if we compare GPE final with GPE initial. GPE final will be lower than GPE initial. Or simply we can say in this case, GPE has been decreased, that kinetic energy has been increased, that the total energy is conserved. So that's all what we need to understand. So let me show you how you can write down your answer. In order to write down a proper answer, you can write down your answer like this. The first point you can say in this case GPE has decreased, and this is 1 mark, means M mark. And the second mark is if you have written total energy is conserved, so kinetic energy has increased. So if you have written these points, you will get 2 marks. For this question, you have to mention gravitational potential energy has decreased. If you will write this one, you will get the marks. If you will not write down gravitational potential energy has decreased, you will get 0 marks for this question because this is M mark. If you simply write down kinetic energy has increased, so this can be the statement, but you also need to explain, state and explain. So explanation is must. If your explanation is wrong, you will not get any. Welcome to A-Level and AP Physics. In today's class, we will discuss past paper questions on mechanics from May June 2022, paper 2. In this class, our main focus will be on kinematics, forces, work, energy, and power. And we will discuss these topics by solving past paper questions. Watch video carefully and try to improve your conceptual understanding of these topics. Let's study together. Let's improve together. We need to define velocity. Velocity is equal to change in displacement over time, or simply you can say displacement over time. But speed is equal to distance over time. Speed and velocity, they are the same. Means they have the same magnitude if the body is moving in a straight line. If the body is not moving in a straight line, velocity means the magnitude of velocity is not equal to speed. And also you need to understand velocity is a vector, so it has direction, but speed is a scalar. For this question, simply we need to define velocity, and this question has only 1 mark. So you can say change in displacement over time, or simply you can say displacement over time. So this is how we can define velocity. This question has 1 mark and this is B mark, mean it has to be in your answer. If we go to part B, it is given to us a constant driving force of 2400 Newton. The car accelerates from rest in a straight line along a horizontal road. Assume that the resistive forces acting on the car are negligible. We need to calculate acceleration of the car. So in this case, you can see we have a car, and on this car, a constant force is acting. So this is the car. Mass of this car is given. So simply we can say mass of this one is 1200 kilograms, and the force acting on this one, force is given. And this is the only force acting on this car. There is no air resistance, there is no friction. So the force acting on this car is given, that is equal to 2400 newtons. We need to calculate acceleration. So we need to use F net is equal to MA. F net in this case is equal to 2400 and mass is equal to 1200 times A. So we can calculate A from here. That will be equal to 2400 divided by 1200. So our final answer will be 2.0 meters per second per second. It's better to write down up to 2 SF because the least number of SF in raw data is 2. So it's better to write down up to 2 SF, means 2 significant figures. This question has only 1 mark. If you got the right answer, you will get this mark, and that is answer mark. So this is how mark will be awarded to you. For the second part on figure 3.1, we need to sketch a graph showing the variation with time t of the velocity of the car for the first 20 seconds of its motion. So the first thing we need to understand, this car is starting from rest. So the initial velocity of this car is equal to 0. Acceleration of this car we have just calculated in part D1, that was equal to 2.0 meters per second. We need to find the velocity. We can find the final velocity if we have value of time. T is given to us after 20 seconds. So the T is equal to 20 seconds. So we can find out the final velocity of the car. Final velocity will be equal to U plus AT. U is equal to 0, but A is equal to 2 and T is equal to 20 seconds. So the value of final velocity will be equal to 40 meters per second. So this is value of final velocity. Initial velocity we have 0, so it means that we have to start our graph from this point. The second thing we need to understand, acceleration is constant. It means that the gradient of the line has to be constant and acceleration is positive. So it means gradient of the line has to be positive. So we can say gradient has to be positive because car is speeding up. And the second thing, it has to be constant, means the gradient of the line, it has to be positive and it has to be constant. And the final velocity has to be 40. So this is the final velocity and here we have initial velocity. Now simply we need to draw a line and we need to connect these points. So simply we need to draw the line, so we can start our line from here and we can connect this. So this is how you need to draw this line. You also need to label this line. So this is, we can label this is A. So this line we need to label with letter A. This question has 2 marks. The first mark you will get if the gradient is positive and gradient is constant and the line is starting from the origin. So you will get 1 mark if gradient is positive and gradient is constant, plus starting from origin. If the line is starting from origin, you will get 1 mark. Origin, if you do this much, you will get 1 mark, and that is M mark, means you will get 1 mark. And the second mark is answer mark if the line end at this point, ending at 20, 40, you will get the second mark, and that is answer mark. But if you can't get M mark, you will not get A mark as well. Means if you draw the curve or you draw this line with negative gradient or it is wrong, you will get 0 mark. So first of all, the gradient has to be positive, it has to be constant, the line has to start from the origin, you will get this mark, and the second mark you will get if the line end at 20, 40. So this is how marks will be awarded for this question. For part C, it is given to us in reality, means in real life a resistive force due to A resistance acts on the car in B. This resistive force increases with speed. Very important point. Resistive force is increasing with speed until it becomes equal in magnitude to the driving force at time t is equal to 12 seconds. So this point is also very important. For part C1 on figure 3.1, we need to sketch a second line to show the variation with time of the velocity v of the car for the first 20 seconds of its motion. And we need to label that line with letter V. First of all, let's sketch and try to understand what is happening. Initially, we have this car, and the only force acting on this car was 2400. So this was the force acting on car, and this was the driving force. So in this case, at time t is equal to 0, we can simply say at t is equal to 0, F net is equal to 2400 newtons. And acceleration we have calculated, that was 2.0 meters per second, and this is happening at t is equal to 0. After some period of time, at this moment, the force, means the driving force, is not changing, so it is still 2400, but now the car is moving, so it means that there is a resistance, there are resistive forces, so we can say F air. Now if we calculate F net in this case will be equal to 2400 minus Fa. So it simply means that F net is smaller than before. So the acceleration, we can say A1, this will be lower than A. So this is happening at time T1. Now after a certain period of time, let's say at time T2, driving force is still 2400 newtons and A resistance has increased now as compared with at time T is equal to T1. So this is Fa. It has increased because it is depending on speed. As speed increase, this force also increase. So in this case, F net will be even smaller than this value and also smaller than this value. So F net has decreased. And A2, this will be smaller than A1 and A1 will be lower than A, means initial acceleration. So this is happening at T2. And finally, what we will see is this force is 2400 and A resistance is also 2400. In this case, F net will be equal to 0. So the acceleration A3, this will be equal to 0. And this is happening at T3, that is equal to 12 seconds. So at T is equal to 12 seconds, these two forces are equal in magnitude. So at 12 seconds, let's say at this point. After that, speed is not changing. So simply we have to draw horizontal line because the speed is not changing after that. So this is one thing we have to draw, horizontal line. Now the second thing you need to understand, acceleration is decreasing all the time. And gradient of this line is equal to acceleration. Gradient is equal to acceleration. As acceleration is decreasing, it means gradient of the line has to decrease. Initially, gradient is equal to the gradient of line A. So simply we can draw, we have to start from origin. We need to draw initially same gradient, then the gradient has to decrease with time, And finally, gradient has to be equal to 0. So this is how you can draw line B, means curve B. This question has 3 marks. If you have drawn this line from the origin and this line is always below line A, you will get 1 mark. And the second mark you will get if the gradient of this line is decreasing. And the third mark you will get if you have drawn the horizontal line between T is equal to 12 seconds and T is equal to 20 seconds. You will get third mark. This is how marks will be awarded for this question. So the terminal velocity at this point, it has to be lower than velocity of the car, means the velocity of the car when there was no resistive force. So it has to be below this one. For the second part, it is given to us at time T is equal to 20 seconds. The driving force is increased to 3000 newtons and remains constant at this value. We need to describe how the velocity of the car changes due to this increase in the driving force. Now, first of all, we need to understand at time T is equal to 20 seconds, car has constant velocity. So simply we can draw forces acting on this car. We have driving force of the car and there are resistive forces acting on this car. We can simply say FR, resistive forces. And magnitude of resistive forces is equal to 2400 newtons. At this moment, car has constant velocity, or simply you can say it has constant terminal velocity. We can say this is V naught. Now, if we increase this driving force from 2400 to 3000 newtons, there will be net force on this car. And net force will be equal to 600. As there is net force acting on the car, this car will accelerate. Accelerate simply means that car will speed up. And when this car will speed up, resistive forces will increase. And finally, car will reach constant velocity. We can say V nu. And this velocity is also constant. So we can also say this is the maximum speed of the car. And this V nu will be greater than V naught because car speed up. So V nu has to be greater than V naught. Then that's all what you need to understand to answer this question. This question has 2 marks. Simply you can say car has acceleration, so car will speed up, means the speed of the car will increase and car will reach a new maximum speed. So this will be 1 mark and this one will be another mark. Let me show you how you can write down the answer. This is how you can write down the answer. So if you say as the car has an acceleration, velocity will increase, you will get 1 B mark, and the second B mark you will get if you will say car reaches a new maximum speed. You will get the second mark. So this is how marks will be awarded for this question. For question number 4, part A, it is given to us a mass small m moves a vertical distance delta h in a uniform gravitational field and gains gravitational potential energy delta EP. Acceleration of free fall is g. We need to use concept of work done to show that change in gravitational potential energy is equal to mg delta h. So we need to use concept of work done. First of all, let's try to understand what is given to us. Imagine that this is ground and one's mass is placed on this ground and mass is small m. We raise this mass up to certain height. In this case, the height given is delta h. So we raise this mass up to height delta h. So this is height delta h. When we raise this mass up, there are 2 forces acting on this one. One force, simply you can imagine that force is force of gravity, that is equal to mg. This force is acting vertically downwards and we are lifting this mass up. So we have to apply force equal to force of gravity to lift this mass up with constant velocity. Let's say the force applied on this mass by us is equal to F and F is equal to mg. Now we need to calculate work done. If we look at work done by mg, so we can write down work done by gravity. So work done by gravity in this case will be equal to force of gravity times displacement, means the vertical displacement. Vertical displacement in this case is equal to delta h. But if you look at the angle between force of gravity and the vertical displacement, angle is equal to 180 degrees. It simply means that the work done by gravity is negative. So we can write down this is negative Fg delta h. And this one is equal to negative mg delta h. So in this case, you need to understand work done by gravity is negative because gravity is acting vertically down and the mass is lifted vertically upwards. So the work done by gravity is negative. You can also understand this point in a little bit different way. If work done by gravity is negative, we can say if work done by gravity is negative, then gravitational potential energy will increase. So gravitational potential energy increases if work done by gravity is negative, and gravitational potential energy decreases if work done by gravity is positive. If work done by gravity is positive, GPE will decrease. So this is also you need to understand. I mean, when the object is falling, work done by gravity is positive, so gravitational potential energy of the object is decreasing and object is gaining kinetic energy if there is no air resistance. So very important point you need to understand. Let's try to calculate work done by F, means work done by applied force. So we can say work done by applied force will be equal to force applied times the vertical displacement. In this case, angle between force and vertical displacement is equal to 0 degrees. So simply we will get F times delta H. So this is the work done by force. But force is equal to the force we applied. That force is equal to mg because the body is moving with constant velocity. So simply we can replace F with mg. So we got mg delta h. In this case, work done by F, again we can write down work done by F. This is equal to change in gravitational potential energy simply you can say this is equal to delta EP. And this is what we need to prove for this question. This question has 2 marks. The first mark you will get if you have written work done is equal to force time displacement, you will get 1 mark, and this is M mark, means it has to be in your answer. And the second mark is answer mark if you have shown that work done is equal to gain in gravitational potential energy, and that is equal to mg delta h. You will get the second mark. For the answer of this question, simply you need to write down this part. Rest is just explanation. So this part I explained to you so you can get clear picture of this question. For the sake of answer of this question, simply you need to write down work done is equal to force time displacement. Force is equal to mg and vertical displacement is equal to delta h. So the work done is equal to mg delta h, and work done is equal to delta ep. For part B, it is given to us a 0.6 kilogram mass is attached to a string which is wrapped around the wheel of a generator as shown in figure 4.1. You can see here we have generator and here is a wheel and the string is wrapped around the wheel. So simply you can imagine that this is a wheel and the string is wrapped around this one. So this is circular. The mass is held stationary over the floor. When released, the mass initially accelerates and then falls at a steady speed and spins the wheel. The generator causes a current in the resistor and a resistance is negligible. State the main energy change when the mass is falling at a steady speed. Now we need to understand, as the mass is falling with constant speed means it's falling with a steady speed. So it means that the mass is falling, so the mass is losing gravitational potential energy. So simply we can say in this case mass is losing GPE. So we can say GPE is decreasing. As the gravitational potential energy is decreasing, that energy has to be converted into an other form. For this question, it is given to us there is no A resistance and the mass is moving at a constant speed. It means there is no gain in kinetic energy and there is no loss of kinetic energy. So simply we can say delta K is equal to 0. Now if you look at this wheel, there is a spring wrapped around the wheel. So there is friction between wheel and the string. So sum of energy will be converted into thermal energy due to friction here, due to friction between string and the wheel. Next thing we need to understand, this generator, when the wheel is rotating, the mechanical energy of the wheel that will be converted into electrical energy by generator. So we can simply write down here electrical energy. The purpose of the generator is to convert mechanical energy into electrical. But when generator will convert mechanical energy into electrical, some of the energy also will be converted into thermal energy because no generator is 100% efficient. And then there will be electrical energy in this circuit. So when current will flow through this resistor, electrical energy also will be converted into thermal energy. So this is the main change in energy. So we have first of all GPE, means GPE is decreasing and this GPE is converted into thermal energy. That's all what is happening in this problem. And this is how you can write down your answer. If you write down this one, you will get 1 mark and that is B mark. Means this has to be in your answer. For part C, it is given to us when falling at a steady speed, the mass in B falls through a vertical distance of 1.4 meters in a time of 4.0 seconds. This causes a current of 90 milliamps in the resistor. The resistance of the resistor is 47 ohms. We need to calculate rate of work done by the falling mass. Now, if you look at this question, it is given to us the mass has fallen through a distance of 1.4 meters. So simply we can write down in this case delta H is given, that is equal to 1.4 meters, and the time taken is given, that is equal to 4.0 seconds. We need to calculate rate of work done by the falling mass. Rate of work done by the falling mass is equal to power, and power is equal to work done. Power is equal to work done by mass divided by time taken. And work done in this case is equal to decrease in gravitational potential energy, because the work done by gravity is positive. So it means this mass is losing gravitational potential energy. So we can simply write down this is equal to delta mgh, means this is equal to change in gravitational potential energy divided by time taken. Simply we can say this is equal to mg times delta h, because mg is constant, so we can say mg delta h divided by delta t. In this case we have value of mass. Value of mass is 0.60 kgs, then g is equal to 9.81, and decrease in height is 1.4 meters, and simply we can divide this one by time taken, that is 4 seconds. So our final answer in this case will be equal to 2.1 watts. So this is rate of work done by falling mass, and this is our final answer. So simply we can write down here 2.1 watts. This question has 2 marks. The first mark you will get if you have written power is equal to work done over time, or if you have written mg delta h over delta t, you will get 1 mark, and this is C mark. And the second mark is answer mark. If you have got the right answer, you will get second mark. For the second part, we need to calculate the power dissipated in resistor. It is given to us in this question that current through the resistor is 90 milliamps and resistance of resistor is 47 ohms. So simply we need to use P is equal to I square times R. Value of I is given, that is equal to 90 milliamps. So we have to convert this one into amps. And we need to multiply this one with resistance. Resistance is equal to 47. So if we just multiply this one, our final answer will be 0.38 watts. And this is the final answer. This question has 2 marks. The first mark you will get if you have written the formula, means you have written this equation. And the second mark is answer mark. If you have got the right answer, you will get 2 marks. For the last part, we need to calculate efficiency of generator. But in the previous parts, we have calculated rate of work done by falling mass. So simply we can say P of falling mass. P of falling mass we have calculated, that was equal to 2.1 watts. We have also calculated power dissipated in resistor. Power dissipated in resistor, and value of that one was equal to 0.38 watts. Now we need to understand what is input power to the generator. P of falling mass, this is the P input to generator, means power input to the generator, and P dissipated, this is P out of generator. So simply we can write down this is our generator, we have P in and we have P out. We need to calculate efficiency, so we can simply say efficiency will be equal to P out divided by P in. P out in this case is equal to 0.38 and P in is equal to 2.1. If we solve this one, our answer in this case will be equal to 0.18. So this is the efficiency, but we can convert this one into percentage efficiency. So we have to multiply by 100. So this one will be equal to 18%. So the efficiency of this generator is equal to 0.18 you can write down, or you can write down in percentage. So this is also okay if you write down in percentage. So you can just simply write down 0.18, you can write down 18%. And this question has 2 marks. The first mark you will get if you have used this formula for efficiency, and that is C mark. Then the last one is the answer mark if you have calculated correct value of efficiency. So this is how marks will be awarded for this question. And that's all for today's class. And in next class we will talk about waves, and then we will discuss about electricity and radioactivity. If you have any questions, please leave your questions in comments and I will answer as soon as possible. Take care of yourself. Bye for now. Welcome to A-Level and AP Physics. In today's class, we will discuss past paper questions on waves from May June 2022, paper 2. In this class, we will discuss waves, intensity, and Young's double slit experiment. We will discuss these concepts in detail by solving past paper questions. So watch the video carefully and try to improve your conceptual understanding of these concepts. Let's study together. Let's improve together. For question number 5, part A, it is given to us light rays from the sun are incident normally on a magnifying glass. The magnifying glass directs the light to an area of radius r as shown in figure 5.1. The magnifying glass is circular in cross section with a radius of 5.5 centimeters. The intensity of the light from the sun incident on the magnifying glass is 1.3 kilowatts per meter square. Assume that all of the light incident on the magnifying glass is transmitted through it. For part A1, we need to calculate power of the light from the sun incident on the magnifying glass. Power of the light from the sun. So in this case, we need to understand intensity of light. Intensity is equal to power over area. But for this question, we need to calculate power. So simply we can rearrange this one. We can simply say power will be equal to intensity times area. Intensity times area. Intensity is given to us. The value of intensity is 1.3 kilowatts. So we have to multiply this one with 1000. And area we can calculate from here because the radius is given to us. And the radius is 5.5 centimeters. So we can say pi r square here, and we need to plug in value of radius. So intensity we have here, and pi is a constant, and we can multiply this one with radius square. So 5.5 times 10 to negative 2 square. If we solve this one, we will get value of power that is equal to 12 watts. So the answer for this question is 12 watts. This question has 2 marks. The first mark you will get if you have written this formula. If you have written this formula, you will get 1 mark, and that is C mark. And the second mark is answer mark. If you have got the right answer, you will get second mark. This is how marks will be awarded for this question. For the second part, it is given to us the value of R is 1.5 mm. We need to calculate intensity of the light on area A. So here we have R means the radius of this small circle is equal to R, and value of R is equal to 1.5 mm. And area of this small circle is equal to A. We need to calculate intensity of the light on area A. Already we have calculated power of the light incident on this magnifying glass. In this question, it is also given to us all the light incident on magnifying glass is transmitted through the magnifying glass. So it means that the power of the light reaching this area, that is equal to 12 watts, because no light is absorbed by magnifying glass. So the power of light reaching at this point is also equal to 12 watts. We need to calculate intensity, so simply we can use this formula. Intensity is equal to power of light, power divided by area. In this case, power is equal to 12, and area we need to calculate. So simply we can use formula pi r square because this is circular shape. So now simply we need to plug in values. We have pi here, and value of r is 1.5 mm. So we need to multiply with 10 to negative 3, and we need to take square of this. If we solve this one, our answer will be 1.7 times 10 to 6 watts per square meter, and this is value of intensity on area A. So simply we can write down our answer is 1.7 times 10 to 6. This question has only 1 mark, and that is answer mark. If you have got the right answer, you will get this mark. Now in this case, one thing you need to understand, that is the main concept. Power, you see, if power stays same and you reduce the area, intensity will increase. So the intensity intensity of light at magnifying glass and intensity of light on this area A is different because area has been decreased, so intensity has to increase. Even power is the same, means same amount of energy per second is reaching this magnifying glass and also reaching this area, this smaller area, but here intensity is greater because area is smaller. So the intensity depends on area. If you reduce the area, intensity will increase. If increase the area for the same power of light, intensity will decrease. Very important concept. You need to understand intensity depends on area. For part B, it is given to us a laser emits a beam of electromagnetic waves of frequency 3.7 times 10 to 15 in a vacuum. We need to show that wavelength of the waves is equal to 8.1 times 10 to negative 8. First of all, we need to understand these are electromagnetic waves, means types of wave and type of medium. In this case, medium is vacuum and waves are electromagnetic waves. So the speed of electromagnetic waves in vacuum and in air is equal to 3.0 times 10 to 8 meters per second. So simply we can say this is speed of EM waves. Speed of all EM waves means from radio to gamma waves, they have the same speed in air and also in vacuum. So we can say this is speed of electromagnetic waves in vacuum and also in air. So this is the main concept you need to understand. Now we need to calculate lambda, but frequency of electromagnetic waves is given, that is 3.7 times 10 to 15 hertz. We need to calculate lambda. So this is what we need to calculate. So simply we need to use V is equal to F times lambda. From here we can calculate value of lambda. That will be equal to speed of waves divided by frequency of waves. Speed of waves is 3.0 times 10 to 8 meters per second and frequency of waves is given, that is 3.7 times 10 to 15 hertz. If we solve this one, our final answer will be 8.1 times 10 to negative 8 meters. And this is the wavelength of these electromagnetic waves. This question has 2 marks. The first mark you will get if you have used this formula, and the second mark you will get, that is answer mark, if you have got correct value of wavelength. So this is how marks will be awarded for this question. For the second part, we need to state the region of electromagnetic spectrum to which these waves belong. First of all, let's try to write down this one in a simpler form. If we multiply this by 10 and we divide this one by 10, there is no difference. So we multiply this one with 10 and we divide this one by 10. Simply we can say here we have this is 8.1. We can say this is divided by 10 and here we multiply with 10. So here we multiply with 10. So the power of this one is 1. If we simplify this, we can write down our answer here. We will get this is equal to 0.81 times 10 to negative 7 meters. So this is value of lambda. Now we need to find out region of electromagnetic spectrum. If you look at visible light, this is from 8 times 10 to negative 7 to 4 times 10 to negative 7. So it means this is not in this region. So this cannot be the region of electromagnetic spectrum, because this value is smaller than 4 times 10 to negative 7. Now, if we go to ultraviolet, you can see the range of this one is from 3 times 10 to negative 7 to 8 times 10 to negative 8. So it means that this belongs to ultraviolet. So here we need to write down this belongs to ultraviolet. Simply you can say this belongs to UV. So the answer for this question is ultraviolet, and this question has only 1 mark, and that one should be B mark. If you have written ultraviolet, you will get 1 mark. This is how marks will be awarded. It's very important if you can remember this range of wavelengths. In multiple choice questions, most of the time they will ask you one question about EM spectrum. For our third part, it is given to us the beam from laser now passes through a diffraction grating with 2400 lines per millimeter. A detector sensitive to to the waves emitted by the laser is moved through an arc of 180 degrees. In order to detect the maxima produced by the waves passing through the grating as shown in figure 5.2, we need to calculate number of maxima detected as the detector moves through 180 degrees along the line shown in figure 5.2, and we need to show our working. We need to find number of maxima detected. So the first thing you need to understand, this question is about diffraction grating, and for diffraction grating we need to understand d sine theta. This is equal to n times lambda. For this question we need to calculate n. So first of all we will calculate only n, and then we will calculate maximum number of maxima. So if we rearrange this one, we can write down n will be equal to d sine theta divided by lambda. Now simply we need to plug in values and we can find value of n. We need to understand which angle we have to take. So in this case you need to understand angle is taken from the center maxima. Center maxima means from the center bright fringe. So if we draw the line here, you can see this angle is 90 degrees. So theta in this case is equal to 90 degrees. So simply we can write on here, in this case the angle we need to consider for the maximum number of maxima or bright fringes, angle has to be 90 degrees. So theta is equal to 90 degrees. Wavelength we have already, it was given to us. Now we need to find out d. In order to calculate d, we need to understand d is equal to 1 over n. But for this question, it is given to us, we have 2400 lines per millimeter. So it simply means that we can write down this is 1 over, we have 2400 lines per millimeter. Or we can simply write down we have 1 millimeter, that is divided into 2400. And other way to write this one, this is millimeter, we need to convert into meters now. 1 millimeter is equal to 10 to negative 3 meters. So here is meter, and this is divided by 2400. So this is the value of d. So simply we can say this is value of d. Now we need to plug in this value of d in the equation and we can find out value of n. Let's plug in these values. So d in this case is equal to 10 to negative 3 divided by 2400. We have sine of 90 degrees and value of lambda we have already calculated. That was 8.1 times 10 to negative 8. Now if we solve this one, our answer will be 5.2. So this is number of bright fringes on one side, but fringes cannot be 5.2. So only possible number of fringes we can have in this case is 5. So you need to understand number of fringes cannot be 5.2. Number of fringes can be 1, 2, 3, 4, 5, 6, 7, 8. But they cannot be. They has to be integer. They cannot be 5.2. So it has to be 5. Even for example, so let me give you one example. Let's say we got n is equal to 5.8. Again, you have to consider 5. So you have to round down. So you have to write down the next closest integer, smaller, not greater. So next one is 5. So we have to take positive integer, but it has to be smaller one, not higher one. So in this case, you have to take 5, not 6. Let's say if you got n is equal to 5.8, still you have to write down 5. So the number of bright fringes on one side of center maxima, in this case we have 5. So simply we can write on here, here is 1 and here is second, here 1 we will get third, and here we will get fourth, and here we will get fifth. So we have 5 here. Also there will be 5 on other side as well. So here also we will have 5 bright fringes or maxima. Question is asking us total. So we can write down n max will be equal to 2n plus 1. So this is the center bright fringe. This is the center bright fringe. So we can simply say this is 2 times 5 plus 1. So this will be equal to 11. So in this case, total number of bright fringes we will see on the screen, they are equal to 11. So the answer for this question is 11. So this is very important point because bright fringes cannot be 5.2. So only possible is they can be 5. Even you got answer 5.8, so bright fringes cannot be 5.8. They can only be 5. So you have to take the lower integer, not the higher one. Let me explain to you how marks will be awarded for this question. This question has 4 marks. You will get the first mark if you have written this formula. You will get 1 mark, and that is C mark. And the second mark you will get if you have written D is equal to this, and this is second C mark. And the third mark is B mark if you have got right value of n. And the last mark is answer mark. If your answer is correct, you will get last mark as well. So this is how marks will be awarded for this question. For the last part, it is given to us the laser is now replaced with one that emits electromagnetic waves with a wavelength of 300 nanometers. We need to explain without calculations what happens to the number of maxima now detected. Assume that the detector is also sensitive to this wavelength of electromagnetic waves. So this question is also about diffraction grating. So now we need to understand lambda has been changed. So first of all, let's try to find out. We have the previous value of lambda that was equal to 8.1 times 10 to negative 8. Now we have new value of lambda. So simply we can write on here lambda new, that is equal to 300 times 10 to negative 9. Now if we multiply this one with 10 to 1 and if we divide this one by 10, so we can simplify this one. So we have 300, this is divided by 10, and here we have this is 10 to negative 8. Now in this case we can cancel this 0 with this one, so we got this is 30 times 10 to negative 8 meters. In this case lambda nu is greater than lambda naught. It simply means that lambda has been increased. So the first thing we need to understand, in this case lambda has been increased. As lambda has been increased, simply we can look at diffraction grating equation. D sine theta is equal to n times lambda. From here we can write down n will be equal to d sine theta divided by lambda. In this case d is the same. We are using the same diffraction grating, and maximum angle is also the same. So if lambda has been increased, it means number of maxima will decrease. So that's all what we need to say. And this question has 2 marks. Let me show you how you can write down your answer. So this is how you can write down your answer. If you have written lambda has increased, you will get 1 mark, and that is M mark. Then if you have written number of maxima decreases, you will get 2nd mark, and that is A mark. But if you have written number of maxima decreases, but you haven't explained that lambda has increased, you will not get A mark, because you need to get first of all M mark, then you can get A mark. Welcome to A-Level and AP Physics. In today's class, we will discuss past paper questions on electricity and radioactivity from June 2022, paper 2. In this class, we will discuss concepts about these 2 topics. Means we will talk about electricity and radioactivity. And we will try to improve our understanding of these 2 topics by solving past paper questions. Let's study together. Let's improve together. For our question number 6, part A1 on figure 6.1, we need to sketch the IV characteristic of a filament lamp. Simply, we need to sketch IV curve for filament lamp. For filament lamp, we need to understand as voltage increase, more electrical energy is converted into thermal energy. As more thermal energy is produced, temperature of filament lamp will rise. As temperature rise, resistance of filament lamp increases. We have to use this concept and we need to sketch the curve. We also need to understand resistance is equal to V over I. If resistance increase with voltage, it simply means that the ratio between V and I also has to increase. Means the ratio between these two quantities also has to increase with voltage. Now let's try to sketch IV curve using these concepts. We have discussed as V increase, resistance increases. It simply means that the gradient of the curve has to decrease with increase in V. So this is how we can sketch. And your curve has to be in first and third quadrant, and it has to be symmetrical in these two quadrants. So we can simply say this is first quadrant and this one is third quadrant. It simply means that, you see, in this case current is negative. It means the polarity of the battery is reversed. So let's try to understand what exactly it means. Let's say this is over power supply and here we have one resistor. So in this case, this side is positive, this side of the battery is positive, so current will flow in this way. So we have this curve, means current is positive. This way we are taking current is positive. So this means that now the polarity is reversed. Now this side is positive, so current will flow in opposite direction. So simply we can sketch here. Now this side is positive, so conventional current will flow this way. Here you can see current is flowing this way. We have taken to the right is positive, and in this case current will flow to the left, and we have taken this one as negative. So that's the reason this curve is in third quadrant. This question has 2 marks. First mark is M mark. You will get this mark if this curve is passing through this origin and this curve is in first and third quadrant. So you will get first mark if this curve is passing through origin and the curve is in first and in third quadrant. You will get 1 mark. That is M mark. And the second mark is answer mark. If this curve is symmetrical, it is symmetrical and gradient is decreasing with increase in V. Means we can simply say gradient is decreasing with increase in V. You will get the second mark. This is how marks will be awarded for this question. In this circuit, this resistor is representing filament lamp, and this resistor is also representing filament lamp. So these are filament lamps. For the second part, we need to explain the shape of the line in A1. Means we need to explain the shape of this curve. For this curve, we need to understand, first of all, as V increases, so I will be writing here, as V increases, it simply means that more electrical energy is converted into thermal energy. More electrical energy converted into thermal energy. As more thermal energy is produced, it means temperature of filament lamp rises. So we can say temperature of bulb, or you can say filament lamp increases. As temperature of filament lamp increases, it simply means that vibrations of ions increases. It means ions vibrate faster. So we can say vibrations of ions increases. As vibrations of ions increases, they make very difficult for electron to flow. Means it becomes difficult for electrons to flow. So simply we can say difficult for electron flow. Electrons cannot flow easily. So difficult for electron flow. As electrons cannot flow easily, it simply means that current decreases. So the rise in current decreases. So better way to say this one is, we will say the rise in current with voltage decreases. So we can say delta I means the rise in current with V decreases. It simply means that the ratio between V and I, this ratio increases and this ratio is equal to resistance. And that's all what you need to understand to answer this question. And now if you look at the shape of this curve, you can see the gradient of this curve decreases. This is telling us the ratio between V and I increases because R is equal to V over I. So the ratio between these two quantities is increasing. It simply means that R is increasing. R is increasing. So that's all what we need to understand about this question. Let me show you the answer, how you can write down a proper answer. In order to write down answer for this question, you have to mention three important points. So let me clean this one so you can see what I have written. So these points you have to mention in your answer. If you have mentioned as current increases, temperature of the filament wire increases. As temperature increases, resistance of filament wire means the resistance of wires of filament lamp increases. As voltage across lamp increases, the graph curves means the gradient decreases. It simply means that the ratio between V and I increases, and ratio between V and I is equal to resistance. So it simply means that resistance increases. If you mention these 3 points, you will get 3 marks, and this question has only 3 marks. For part B, it is given to us a conducting wire has length 5.8 meters and cross-sectional area is equal to 3.4 times 10 to negative 8 meters square. Resistivity of the metal wire is also given. We need to calculate resistance of the wire. So simply, this question is very straightforward one. Simply, you need to understand how to use this equation. Resistance is equal to rho L pi A. Now simply you need to plug in values. In this case, value of resistivity is given, that is equal to 5.6 times 10 to negative 8. L is given, that is equal to 5.8 meters, and cross-sectional area is also given, that is 3.4 times 10 to negative 8 meters square. Now simply you need to put these numbers into your calculator and you can find value of resistance. The resistance in this case is equal to 9.6 ohms. So this is our final answer. So simply we can say resistance is equal to 9.6 ohms. This question has 2 marks. The first mark you will get if you have written this equation, means you have written this formula. You will get 1 mark, and this is C mark. And the second mark is answer mark. If you have got the right answer, you will get 2 marks. For part C, it is given to us a resistor of resistance capital R is placed in a circuit with a cell of negligible internal resistance. 2 switches S1 and S2 and a second resistor of resistance 2R and 3 ammeters X, Y and Z. The circuit is shown in figure 6.2. The reading on X is 1.0 amps when switch S1 is open and S2 is closed. We need to complete table 6.1. We can simply write down here first of all case 1. So we will be talking about case 1 first of all. For case 1, it is given to us when S1 is open and S2 is closed, reading on X. So let's sketch our circuit. So this is the circuit now. S2 is closed. So this is what you will see. So this is our circuit now. So this one is our circuit. We can also draw this solid line. So this one is our circuit. If current passing through X means I passing through X, this is equal to 1.0 amps. Then current passing through ammeter Z also has to be equal to 1.0 amps because they are connected in series. So simply we can say current passing through ammeter Z is equal to 1.0. But current passing through ammeter Y, this one has to be equal to 0 because no current will flow this way because this switch is open. So this is case 1. One thing more we need to understand about this case. If we connect our voltmeter between these 2 points, let's say we connect voltmeter here and we connect voltmeter here. So the reading on this voltmeter has to be equal to the potential difference across terminals of this power supply. We can say the potential difference across terminals of this power supply is equal to V. So the reading on this voltmeter also has to be equal to V because switch is ideal switch, means there is no voltage loss, and this ammeter also is ideal ammeter, means its resistance is negligible, so there is no voltage drop across this ammeter. So in this case simply we can say when potential difference is equal to V, current is I, R is the resistance. But in this case current is equal to 1.0 amps passing through this resistor when resistance is 2R. When resistance is 2R. So from here we can say I current is equal to 1.0 amps when potential difference is V and resistance is equal to 2R. So simply we can write down this is our case 1. For the second case, it is given to us S1 is closed, then S2 is open. Means this one, S1 is closed, then this one is open. So we can redraw our circuit again. So you can see now this is our circuit now. So this is our circuit. So we can simply redraw. This one is our circuit. In this case, you can see the potential difference across these 2 points, mean potential difference across this resistor. This one is equal to V. So if you connect your voltmeter between these 2 points, or simply if you connect voltmeter across this resistor, reading on this voltmeter will be equal to V. So we can write down here for second case. Case 2, we have potential difference V. We need to find out current. We can simply say this current we can say is I naught. We can write down this is I naught. So this current we can say this is I1 times the resistance. As V is the same, so it simply means that I naught, V is same. V is same. So this V is equal to this V. We can write down I naught times R. It has to be equal to I1. So we can say this is R naught. I1 times R1. In this case, we need to find out value of I1. So we can write down I naught. So this is I naught times R naught divided by R1. So I naught is equal to 1.0 and R naught, this is equal to 2R. R1 is equal to R. So simply this R we can cancel with this. I1 is equal to 2 times of I naught. So it simply means that I1 is equal to 2 amps. I have written this one in a proper way so you can get good understanding of this point. Otherwise, I can simply say as this resistance is half, V is the same, so current has to be double. So in this case, current passing through X, this one has to be 2.0, and current passing through Y also has to be 2.0, double than current passing through X before. And current passing through Z has to be 0 because there is no current passing through Z ammeter. So this is how you can answer the second case. For third case, it is given to us S1 is closed and S2 is also closed. First of all, let's clean this circuit and redraw. Our circuit is a complete circuit. So this one is a complete circuit now. Means we have here, so this is our circuit, and then we have 2 resistors, they are connected in parallel. So we have 2 resistors, they are connected in parallel. R and 2R, they are connected in parallel. So this is our circuit now. In this case, we will connect our voltmeter again between these 2 points, means between this point and this point. If we connect voltmeter between these 2 points, reading on this voltmeter again will be equal to V. But in this case, we need to understand resistance. We have 2 resistors, they are connected in parallel. So we can find out the total resistance of 2 resistors. We have R and they are connected in parallel. So first of all, you need to multiply, then you need to add these 2 resistors. In this case, we will get this is 2R squared divided by 3R. So this R we can cancel with this. So we got 2 by 3 times R. So this is the resistance. And we can say this is current I2. We need to find out value of I2. Means current passing through X. We can find out value of this. So I2 times R2 we can say. So this is R2. Now in this case, I2 times R2, again it has to be equal to I naught times R naught. We need to find out I2, so we can write down this one has to be equal to I naught R naught divided by R2. I naught is equal to 1.0. We have value of I naught that is equal to 1.0 and R naught. So we can say this is R naught. This is equal to 2 times R divided by R2. R2 is equal to 2 by 3 times R. Now we can simplify this, I'll be writing this one here. So in this case, we can say I2, this one will be equal to 2R divided by 2 by 3R. So simply we can say 3 by 2 times R. So here we have 2 by 3R, or simply you can write down 3 by 2R. So this R will be cancelled with this, 2 will be cancelled with this one. So we got I2, this is equal to 3 amps. So value of I2 is equal to 3 amps. So current passing through X, this has to be equal to 3.0 amps. Now we need to find out current passing through R and 2R. So simply you can say potential difference across R and 2R has to be the same. This resistance is half, so current passing through this one has to be double, and current passing through this one has to be half. So it means current passing through this one will be 2 amps, and current passing through 2R, this one will be equal to 1 amp, because the potential difference across this resistor and this resistor is the same because they are connected in parallel. But current passing through X, this is equal to 3 amps. So this one is 3 amps. Reading on Y means reading on this one will be 2.0 amps, and reading on Z, this one will be 1 amp. So this is how you can write down your answer. I hope this is clear to you. If you have any questions, so please leave your question in comments and I will answer as soon as possible. Let me explain to you how marks will be awarded for this question. You will get 1 mark if you have written these 2 values, and these 2 values are correct. You will get 1 B mark. And second B mark you will get if you got all these 3 values correct. You will get second B mark. And third B mark you will get if you got all these values correct. And the fourth mark you will get if all these values are correct. Then you will get 4 marks. And this question has total 4 marks. For question number 7, part A, it is given to us fluorine 18 is an isotope that decays to an isotope of oxygen by the emission of beta plus particle. We need to complete this nuclear equation for the decay, including all the particles involved. So first thing we need to understand, this is beta plus decay. So simply you can write on here, this is beta plus. So the charge on beta particle is +1 and mass number is equal to 0. Beta plus particle is antiparticle. So in this case, electron neutrino will be emitted. So this will be electron neutrino because this is antiparticle. So this will be neutrino, not anti-neutrino. So this one will be neutrino because this one is antiparticle. So this one has to be neutrino. So this is electron neutrino. Now we can write down atomic number and mass number for oxygen. So you can see here, this is 1. So atomic number here has to be 8. You can see this is 0. This is 0. So it means the mass number of oxygen isotope has to be 18. So if you write down these 3 points, you will get 3 marks. And these are 3 B marks. I mean, if this is correct, you will get 1 B mark, second B mark, and third B mark. For the second part, it is given to us a quark in the fluorine 18 nucleus changes flavor during the decay. State this change of flavor. If you look at this nuclear equation, in this case, you can see on left side we have 9 proton, but here we have 8 proton. But the total number of nucleons, mean the total number of neutrons and protons remains same. It simply means that 1 proton decays into neutron, mean proton decays into neutron, and this is true in beta plus decay. If you look at composition of proton has 2 up quarks and 1 down quark. And neutron, this one has 1 up quark and it has 2 down quarks. It simply means that in this case, 1 up quark decays into 1 down quark. That's all what we need to write down for answer of this question. So in this case, 1 up quark decays into 1 down quark. Or simply we can say up quark changes into down quark. And this question has only 1 mark if you have written this one one, we will get 1 mark, and this is B mark. For part B, it is given to us a hadron as a charge of -2e. E is the elementary charge, and we need to state and explain whether the hadron is a meson or a baryon. So we need to state and then we need to explain. First thing we need to understand, hadrons can be classified into meson and into baryons. Mesons consist of one quark and one antiquark. One quark and one antiquark. So this is composition of meson. Baryons consist of 3 quarks or consist of 3 antiquarks. Quarks are 3 antiquarks. But for meson, it has to be 1 quark and 1 antiquark, but baryons can consist of 3 quarks or they consist of 3 antiquarks. If they consist of 3 antiquarks, we call them antibaryons. Now let's try to find out the charge on meson. First of all, meson. Let's say we have a meson that consists of 1 up quark and it consists of 1 down antiquark. So this is composition of meson. So in this case, the charge on up quark is +2/3e and the charge on down quark is -1/3e. But this is anti, so the charge will be 1/3e. So the total charge in this case will be +1e. Now imagine that we have 1 up antiquark and we have 1 down quark. In this case, charge on up antiquark will be -2/3e and charge on down quark is -1/3e. So the total charge will be -1e. Now if we take 1, let's say, down quark and 1 we have strange antiquark. Charge on down quark is -1/3e and the charge on strange quark is also the same as charge on down quark, but strange quark is strange antiquark, so the charge will be 1/3e. So in this case, charge will be equal to 0, means no charge. From here you can see charge on the meson maximum can be +1e and minimum it can be -1e. Now if we talk about baryon, baryon consists of 3 quarks. Let's say it consists of 1 up quark and it consists of 1 charm quark and it consists of another up quark. In this case, the charge on each up and each charm quark is equal to +2/3. And there are 3 quarks, so the charge will be +2e. It is also possible we have all of them, they are antiquarks. So we have up antiquark, we have charm antiquark, and we have another up antiquark. In this case, we will have charge on each quark that will be -2/3e. So if we multiply by 3, our answer will be -2e. It is also possible we have 1 up quark and we have 2 down quark, as in case of neutron. So in this case, charge on this baryon will be equal to +2/3e -1/3e -1/3e. So the total charge in this case will be equal to 0. So you can see in this case, it is possible that a baryon means antibaryon, it has a charge of -2e. So it means the particle in this case is baryon. It is not meson, because the charge on meson cannot be -2e. So this one is baryon. Now let me show you the answer, how you can write down the answer for this question. This is how you can write down the answer. You can explain this one in 2 different ways. One thing you can say the hadron is a baryon and this has 1 B mark. You can explain this one, you can say must be 3 antiquarks, as largest negative charge on single antiquark is -2/3e. So you will get 2 marks. This is one way to explain. So I can say this is one way. But the second way to explain is you can say hadron is a baryon and meson can only have a charge of 0 or it can have a charge of +1e or -1e. So this is second way to explain this answer. So you can also write down your answer based on meson or you can write down your answer based on baryon. Any explanation is acceptable in this case. This question has 2 marks, 1 mark for the statement and 1 mark for explanation. But you need to understand in this case, this mark is M mark. So you have to explain. You have to explain this one, then you will get 2 marks. If your explanation is wrong, you will get 0 mark. So M mark is for explanation and the answer mark is for writing this is baryon. For the second part, we need to state a possible quark composition for the hadron. We have already discussed hadron is baryon, and the total charge on this baryon is equal to -2e. And this charge is only possible if we have one up antiquark, we have one charm antiquark, and we have one top antiquark. This composition is possible. It is also possible, you can say, baryon consists of 2 up antiquarks and it consists of one charm antiquark. This composition is also possible. We can also write down there is one up antiquark and there are 2 charm antiquarks. This composition is also possible. The charge on one up antiquark is equal to the charge on one charm antiquark, and this is also the same as charge on one top antiquark, and that charge is equal to -2/3e. So all of them, they have the same charge. So these are some possible quark compositions. In this case, we can also write down it is possible this baryon has one charm antiquark and it has 2 top antiquarks. So it has 2 top antiquarks. I'll be writing here up antiquark, and one charm antiquark. Any composition is right. So if you write on any composition here, you will get 1 mark, and this is the mark.